Today we are going to study the Carnot cycle and its contents. First of all, discuss about the introduction of the Carnot cycle, the history, what are the assumptions or PV diagrams, efficiency of the Carnot cycle, limitations, and then conclusion. We'll discuss first of all the introduction of the Carnot cycle. The most powerful and efficient heat cycle consisting of two isothermal and two adiabatic processes. This actually is the idealization because in order to approach its efficiency, the processes involved must be reversible and involves no change in entropy. A system undergoing Carnot cycle is called Carnot engine. Then, what is the history behind this Carnot cycle? It is proposed by Nicolas Leonard Sadi Carnot in 1824. He was a French engineer, founder of the science of thermodynamics, and first one to recognize the relationship between work and heat. That means it explain what is the relationship between the work and heat. Then we discuss about the common assumptions of the Carnot cycle. First of all, isothermal expansion compressions are considered conscious equilibrium. Second, no heat losses in pipes and other components. Then third, the cycles do not have any friction, thus no pressure drops in the working fluid. And next, the changes in kinetic and potential energies are negligible. And then discuss about the PV diagram. In the PV diagram, it covered the four cycles. The first one, 1 to 2 is the isothermal expansion. Then 2 to 3 is the adiabatic expansion. Then 3 to 4 is the isothermal compression. And then 4 to 1 equal to adiabatic compression. These are the four processes occur in the Carnot cycle. Then this from this diagram we can see that what is happening in the process 1 to 2, 2 to 3, 3 to 4 and 4 to 1, and this is the isothermal expansion, and then adiabatic expansion from Ts to T1, then isothermal compression at T1, and then adiabatic compression from T1 to Th. Then next go to the elaboration of this Carnot cycle. From this figure it shows the schematic and accompanying PV diagram of a Carnot cycle executed by the water steadily circulating through a simple vapor power plant. Then next, the steam exiting the boiler expands adiabatically through the turbine and the work is developed. The steam temperature decreases from Ts to TL. Then two-phase mixture flows through the condenser and where heat rejection occurs at constant temperature TL. Then next point, the mixture, liquid and vapor, enters the pump, that is compressor, and it enters the mixture, liquid, vapor enters the pump or compressor, and its pressure increases. This is an adiabatic process and requires input work. The saturated liquid at high temperature enters the boiler where change of phase occurs at constant temperature Th. Then discuss about about the Carnot theorem. No real engine can more efficient than a Carnot engine operating between same two reservoirs. All Carnot engines operating between reservoirs at the same temperature have the same efficiency. Then these are the diagram of proof of Carnot theorem. This is the cold body and hot body combination in which the work and heat interaction takes place. The next, an impossible situation. A heat engine cannot drive a less efficient heat engine. Violation of second law of thermodynamics. If n m greater than n l, then net heat flow would be backwards and into the hot reservoir. Proof of the Carnot theorem for reversible engines and irreversible engines. All reversible engines that operates between the same two heat reservoir have the same efficiency. And irreversible engines, no irreversible engines is more efficient than the Carnot engine operating between the same two reservoirs. They discuss about the efficiency of Carnot cycle. The thermal efficiency of Carnot cycle can be calculated as N thermal equal to 1 minus in bracket QL divided by QH equal to 1 minus in bracket TL upon TH. So called the Carnot efficiency. The higher the temperature of the low temperature sink, the more difficult for a heat engine to transfer heat into it. thus the lower thermal efficiency also. Then discuss about the limitations of Carnot cycle. The isentropic process 1 to 2 is technically not achievable as it is difficult to handle two-phase system. And if the steam quality is poor, then process 3 to 4 is difficult to carry out. Then finally we can conclude that we can say that the Carnot engine is one of the most efficient one but is idle one. This is today we discuss, this is the lecture belongs to the Carnot cycle and its limitations and some important parameter to discuss here. This is the end of the today's session.